Over the next few lessons, you're going to have to do a titration or a series of titrations. To get it started, you're going to need to make a standard solution. A standard solution is one where you know the concentration to at least 3 significant figures, and you know that it's exactly that concentration, which will allow you to find the concentration of other things that are unknown. So what we're going to make is a sodium carbonate solution, and you're going to use that solution to find the concentration of hydrochloric acid. Then once you know the concentration of the hydrochloric acid, you're going to use that to find the concentration of some sodium hydroxide. Gets a bit lengthy here. Then once you know the concentration of the sodium hydroxide solution, you're going to use that to find the concentration of an unknown, for example, the concentration of ethanoic acid in vinegar or something like that. So the idea is, if we go all the way back to the start again, we need to get this totally correct. And we know that we're after a solution that's about 0.05 moles per litre. Now that's only one significant figure for a reason. It's not going to be exactly that when we make it. We're going to have to try to get it to that if we can. Well, to do that, we have to get a mass of our anhydrous salt, so it's had all the water of crystallisation boiled out of it. We're going to have to get a mass of that to dissolve into a particular volume. And you're going to make 250 mils. This is called a volumetric flask. It's got a very, very thin line etched up the top. That's at 250 mils plus or minus 0.15 mils. So it's really, really, really precise. To 3 significant figures, it is 250 mils. Alright, so these are really precise. Please don't drop them. That's only true at 20 degrees Celsius. So if it was, say, 30 degrees, we'd probably have to get the room a little cooler, because of course as it gets hotter, things expand. Alright. What we need to be able to work out the mass of sodium carbonate that we want to get is we need to use these values here in our little triangles. So just remember that we've got N equals C times V. You can do a triangle with that if you want. And M equals N times MR. So I can manipulate these things here to actually find the answer. So if I want to have 0.05 moles per litre in 250 mils, I can actually work out the amount that I need. So here's what I do for the amount of sodium carbonate. Amount is N, and it's going to be the concentration that I want, so 0.05 moles per litre. Sorry, I'm going to leave the units out of my working. And my volume that I'm going to make it up to is 250 mils, but because this is per litre, I need to have my volume in litres. So I'm going to make that 0.250, and that's litres, so a quarter of a litre. So I do that maths, and I'm sorry my mental arithmetic is not good enough for that. And correct me if I'm wrong here, please.
0.0125.
That is 0.0125, cool. Okay, I will put the unit there because that's important for the next stage. So I've got 0.0125 moles. That's the amount of this solid that I want to be in that solution. That's the amount, not the mass. So to find mass, I now go, the desired mass of sodium carbonate is going to be the amount, 0.0125 moles, times its molar mass, which is written on the container, so I don't have to actually look that up, which is 106 grams per mole. Again, my mental arithmetic's not good enough, so I'll need some help there, please.
1.325.
Yeah.
1.35 grams. So that's what we're trying to dissolve in here. Now, to get exactly 1.35 grams is really difficult. So we're not going to worry if we go a little bit over or a little bit under. Because then what we're going to do is we're going to go backwards with all of our calculations.
Yes,
So that's 1.325.
Thank you, so 1.33. Okay.
Yep.
So after we've got about 1.3 grams, which we'll record exactly, we're going backwards with these calculations to find what the actual concentration is.
Yeah, how did you get the 0.05 times 0.25?
The 0.05 comes from my desired concentration. The 0.25 comes from the volume of my flask. Okay, 250 mils converted into litres. Good question. Yep.
So if you work backwards up,
I'll show you that after I've weighed it out. Okay, I'm going to weigh the wrong amount on purpose
okay.
to show you what we do. So, to make the solution, our first step is to weigh it out on our scales, and I normally weigh it out in a beaker, because then I can put some distilled water in here to dissolve most of it, then pour it in, then rinse it out and pour it in. It's just easier than doing it on a, normally you'll see most people do it on a watch glass or something like that. So zero my scales, sorry I should have done it with the beaker on it, it's a bit foolish. Zero my scales with the beaker on it. And I want 1.33, but that's really hard to get. So I'm just going to go until I get about 1.3. It's a fair bit. That's halfway. And whoops, I'm only at 1.31. I'm actually going to go a little bit more because I want to show you how to do it. If you go over. So I've got 1.48, which is too much, but that's okay. Sorry, 1.48. So that's okay. I'm not going to worry about that. So we have to use distilled water for this because we don't want any other ions in there to affect what we've got. Distilled water has been boiled, then recondensed. That's what distillation means. Alright, so my first step is to try to dissolve this as much as I can in here. Then after I've dissolved as much as I can, I pour it in and I repeat that process. Then I top this up with distilled water up to the line. I'm not going to do that part of the process just yet. Alright? The reason is I want to go back to the fact that I had 1.48 grams. So I now need to work out what the concentration really was. So now, over here, I'm going to find out what the real concentration is, which I'll write on this in permanent marker. So, the mass I did have was actually 1.48 grams, which is a bit high. Alright, now from mass, I can find the amount. So, remember, a little way of remembering that one. Okay. So I'm going to go 1.48 divided by 106. So again, I'm going to need your help with that, please.
0.0139.
Okay, so I've got 0.0139 moles. It's a fair bit more than I wanted to have, isn't it? Okay, but that's okay, because through the series of experiments, we just allow for that. Now I've got the number of moles, or the amount, and I know the volume that I've made up, which is 250 mils, I can now find what the real concentration is. So C equals N over V, so 0.0139 over, again, volume, capital letter, so this has to be the unit's capital, which is litres, 0.250 litres. So again, we'll need your help with that, please.
0.0556.
Well, that's not too far removed from 0.05, is it? It's pretty close. Okay, so that's acceptable. If I'd got as high as, say, 0.059, which is basically 0.06, probably need to remake it. If I was as low as 0.04, I need to remake it. But if I'm about 0.045 to 0.055, which this roughly is, then that's okay. That's not going to stuff my experiments up for the next week and a half. Alright? So to make it, as I say, what we're trying to do is to dissolve as much as we can in here, and then pour it in. Try to decant it. We don't really want the solid bits going in here, because these vessels aren't very good for actually doing the dissolving. And then we just repeat the process with distilled water. And this takes a wee bit of time. So that's what you're going to do for the rest of the period, is make your approximately 0.05 mole per litre solution, label it with the name of one of you from the group, plus the exact concentration to 3 significant figures on the actual volumetric flask. Alright, stop.